Hi everyone, and welcome to our video on solving the one unique triangle SSA case with the law of sines. So the law of sines is good, like in this last video, when you have two angles, because you can get the third right away, and then there's nothing weird that's going to happen. So it will flow through just like this problem, and everything's going to be great. However, if they give two sides and one angle, the SSA case, then there's three things that could happen. And it's all just dependent on what's going to happen when we try to solve for our sine of theta once we get it all set up. Okay, so these are the breakdowns of the cases. We're going to show it. So this is the one unique triangle case. Now, when doing these problems, they're not going to tell us which case it is. We're going to have to figure it out, but we'll show why this is the one triangle case. Okay, so it gives two sides and an angle right here. And it's then determine whether the given measurements produce one triangle, two triangles, or no triangles at all. Solve the triangle that results, round to the nearest tenth and nearest degree for sides and angles respectively. Okay, so we're going to use a calculator. All right, well, when I see solve a triangle, I'm thinking, how about I just get my table going? So A equals something, B equals 70 degrees, C equals something, little a equals 7.5 feet, little b equals 8 feet, and then little c equals something. We don't know, so I'm going to box those. So I'm just getting my answer ready. Okay, and then now we need to find the rest. Okay, so when we have this triangle, we cannot assume that we have a right triangle. Remember, right triangles, you would just use SOHCAHTOA. It's a lot quicker and easier. However, if we don't have a right triangle, then we should try the law of sines. So we'll set up our law of sines. So the law of sines is sine of A over little a equals sine of B over little b equals sine of C over little c. And then we'll input what we currently have. So we have sine of capital A over 7.5 equals sine of 70 degrees over 8 equals sine of C over little c. Okay, so currently the C information, they're both unknown, so that one's completely useless for us. What we do want, every time we use the law of sines, we want the one fraction that has complete information, so that's this middle fraction, and setting it equal to something that has one piece of information, and then finding the unknown other piece. So we will use these the first and the second part of the law of sines. So we will say, so we are solving for A in this problem first, for angle A. So we will set it up as sine of A over 7.5 equals sine of 70 over 8. And then it looks like all we have to do is multiply both sides by 7.5. Okay, so if we multiply both sides by 7.5, I'm going to squeeze that in there. We would have sine of A is equal to 7.5 sine of 70 degrees over 8. Okay, so we have this set up. Now, notice we solved for the trig function first with A still in it. And what I want to do is use our inverse property. So I'm going to say, well, if I want A by itself, I can put sine inverse right here on the left, as long as I do it also on the right. So it's squeezed in a little bit, but there we go. So that way I have angle A is sine inverse of the 7.5 sine of 70 degrees over 8. Now again, if we can't use a calculator, this would be the final answer for angle A. And then the problem would probably stop right there if we can't use a calculator. But because we can use a calculator, let's now enter that. Okay, so A is equal to sine inverse. I just want to enter that fraction over there, the 7.5. Okay, so I had that left open from last time. So 7.5 sine of 70, and then all divided by 8. Make sure it's in degrees, so we see it. Yes, it's in degrees, and we get this 0.8810. So we'll round to 4 decimals, so 0.8810. Okay, so there it is to 4. Now, from here, we can enter that into a calculator. Okay, so one more time. I wanted to see that for the decimal though, because now let's use approximately, so we are rounding. Okay, now let's enter that. Okay, so sine, let's go to the function. Sine inverse of that previous answer. That way it's not rounded as much. Perfect. Okay, and we get 61.76 degrees. Okay, so it looks like that's our angle A. Again, with this, we might have one triangle or two triangles. This is where we go back to stating, let's look at this part. I'm going to put it right over here now. The sine inverse of the 0.8810 part. Okay, so we did get an answer from it, but there might be a second answer because right now, we have to go back to our inverse trig knowledge and say, well, this is a y coordinate right here. Okay, and it was a y coordinate even before we introduced the sine inverse. Okay, so we had a y coordinate involved. The sine inverse restricts things, but the regular sine function does not. So what I mean by that is usually when we have an inverse trig function, sine inverse restricts our answer to here in the purple. But we didn't have sine inverse from the start. We had sine of A. Let me do that in pink actually. We had sine of A equal to the same, so this was that same 0.881 in the pink there. So we had sine of A equal to a y coordinate. Okay, so that's that same y coordinate, and the y coordinate is 0.8810. So that means it's somewhere right here, and it's somewhere right here. So we get 2. And so that means we're looking at an actual different interval in this problem because of the sine function versus the sine inverse. So the sine inverse helped us get one angle, but it doesn't help us get the other. And so we did get the 61.76 degrees. Okay, so that was, let's see, I'm running low on colors. Let's just do it right here. So that is that 61.76 degrees right there. And well, all we have to do to figure out the other possible angle is to do the complement, or not the complement, sorry, the supplement. So we want to know what's this angle here that I'm now putting in orange. Well, the 61.76 is this same length right here. So that means we could take 180 and minus the 61.76 to get the orange. So I'm going to call this A star, because we got A was 61.76. A star every time, or whatever symbols we want to use, is always 180 minus A. Okay, and we can use that from here on out. And it doesn't matter what the letter is. If it's B, we could do B star is 180 minus B. Okay, so it's always just do the supplement. So 180 minus whatever the found angle was. And so when we do that, well, our A star, let's plug that in. So 180 minus 61.76 is 118.24. Okay, but notice this. The angle that we were given, so we were given angle B as 70 degrees. If we had a triangle that had 118.24 as an angle, but we're saying we already have 70 degrees included, notice that those add up to be bigger than 180. So A star plus the given 70 is greater than 180 degrees. So that means that that can't possibly be an angle for our triangle. Okay, because the three angles need to add up to 180. Okay, so this one would not work. So I'm just going to say no good. Okay, so that means the 61.76 is our only angle. So now we can put it in. Let me do it in blue. 61.76 degrees is the only angle that works. Okay, and now that we have two angles, we can find angle C. Okay, so step 2. Okay, so or step 1, step 2. So step 1 was get that whole thing ready. Step 2 is, well, let's find the last missing angle. So we could just do 61.76 degrees plus 70 degrees plus whatever angle C is should add up to 180. Okay, so let's get that C solved for. So I'm just going to do it in a calculator real quick. 180 minus 61.76 minus another 70 is 48.24. Okay, so there's our angle C now. Let me do it in blue to say we found it, 48.24. And then now the last thing we need is that side C. So the third step in this problem is back to our law of sines right here. Again, it might be just worth boxing that. So usually we recycle the law of sines at least twice in these problems. Okay, so we have angle C now, though, in this setup. So that means I could take the middle equation. So sine of 70 over 8, or the middle part of the equation, so sine of 70 over 8 should equal sine of the angle we just found, 48.24, over that missing final side, C. Okay, and then now it's cross multiply, so we would have C sine of 70 degrees equals 8 sine of 48.24 degrees. And then we'll divide both sides by sine of 70. So we have little c is 8 sine of 48.24 degrees over sine of 70. And then now we can finally go back to the calculator, plug all of that in, and have our final little c answer. Okay, so we've got 8 sine of 48.24 all divided by sine of 70. So 6.35. And that would be in feet. Okay, and then to finalize it, let's just put it in the table, 6.35 feet. Okay, so there's everything. Again, notice the quick check, my biggest angle is 70, which does have the biggest side, 8. My smallest angle is 48.24, which has the smallest side, 6.35, and then the one in between has the medium side. Okay, so at least that's looking good. Okay, but that's it. Again, the law of sines. Okay, so the law of sines, just like in this one, just repeating over and over again. If you are finding an angle, though, if you're finding an angle, make sure to look at the supplement and see if the second angle makes sense for another triangle. Okay, so on this one, it did not make sense because it was bigger than 180 when added to the original angle that was given. All right, so that's that. If you have questions, please let me know. Otherwise, thanks for watching.